when a lead-acid car battery is recharged by the alternator, it acts essentially as an electrolytic cell in which solid lead-2 sulfate, or PbSO₄, is reduced to lead at the cathode and oxidized to solid lead-2 oxide, PbO, at the anode. Suppose a current of 42.5 ampere is fed into a car battery for 45 seconds. Calculate the mass of lead deposited on the cathode of the battery. So if you're given electrolysis problems and you're being asked for the mass of a certain metal deposited on the cathode, there's just one formula that you're going to use for this, and I hope you memorize this formula. So mass is equal to the molar mass of that metal times the current in ampere times the time in seconds divided by the number of electrons transferred and then Faraday's constant. Okay, so in the problem, we are given lead. So you look at your periodic table and you'll see that the molar mass of lead is 207.2. So that's grams per mole. Times I is the current in amperes. So we're given 42.5 amperes. Remember, ampere is just the same as coulombs per second. So C over S. So let's just rewrite that as C over S. Times T in seconds. So we're given 45 seconds. Okay, and the denominator is N is the number of electrons. So if you look at the problem, it says here you have lead-2 sulfate, so lead-2, meaning you have lead with a positive 2 charge, and it is reduced to lead. So from positive 2, it just becomes lead with a 0 charge. So from positive 2, it becomes 0, meaning it gained 2 electrons. So there are 2 electrons involved in the process. So you put here 2, and then F is the Faraday's constant, which you should memorize. That's 96485 coulombs per mole. That's the Faraday's constant. So let's see how the units cancel out. So the coulombs will cancel, the seconds would cancel, and the moles would cancel. So we're left with grams, which is the unit for mass. So solving this in your calculator, we have 207.2 multiplied to 42.5, and then multiplied to 45, divided by 2, and divided by 96485, and the answer is 2.05 grams. And we're